Look at the top questions from Microsoft, which is the LeetCode course, which covers many of the questions that you would expect to find in a Microsoft interview. Today we're going to look through TwoSum. So TwoSum is a pretty common problem that seems to be asked in interviews. Basically, you're given an array of integers, such as this one over here, and you have to return the indices of the two numbers such that they add up to the specific target. So in this case, it's 9, and the answer is 0 and 1 because the 0th index, which is 2, adds up to the first index, which is 7. And that adds 2 plus 7 is 9. So that's the answer over there. Basically, how we're going to go through this is I'm going to provide a logical visual explanation on how this is done, following which we'll work through the code on this.
So let's visualize this TwoSum problem. We'll start with the example array we've been given, which has 2, 7, 11, and 15. Our target is 9. And we're trying to solve this in one pass, which is linear time O of n. The way we're going to do this is we're going to create a hash map. So let's say we have an unordered map. Integer pair. Let's name it hash. So how our keys and values are going to look in this map is our keys are actually going to be the values in the array we've been given, 2, 7, 11, and 15, and our values are going to be the indices. The reason being is that if you notice, the return type is actually a vector of integers. 2 integers, which will be the indices that add up to the target 9. So in this case, our answer is going to be 0 and 1 because the 0th index 2 plus the first index 7 adds up to 9. Anyway, initially, there's nothing in our hash map. No, absolutely nothing in there. Let's see how we actually go through with this. So the first step is we're going to calculate this value, which is target minus the current element. So for our first element, we're going to have 9 minus 2, which is equal to 7. Second step is going to be we're searching for hash of val, which is the value we just found. So in this case, it's going to be hash of 7. As you can see, our hash table is completely empty right now. So we move on. We haven't found hash of 7. So now we just add the current element, nums of I, and we give it a value of the index. So we're going to have 2 and its value 0. So these are the 3 steps we go through. We calculate the target minus the current element. We search for the hash value of the value we just found. And if we can't find that, then we add the current element to hash, and we give the value of that key as the index. So let's move on to the second element now, which is 7. So value here is going to be 9 minus 7, which is equal to 2. Then search for hash of val, which is right over there. So hash of val is hash of 2. And there it is. So we have the key 2 and the value 0. Now that we've found it, we have a solution vector which we should have made. And what we want to do is push back two values to this vector. First, we're going to push back hash of val, and then we're going to push back the current element, which is I. So, and then we return the vector, obviously. So in this case, hash of val, which is hash of 2, is 0. So that's the first element in our vector. And then we push back the current element, which is 1, which is 7, but the index of it, so it's 1. And that's our answer, because the 0th index 2 plus the first index 7 adds up to the target, which is 9.
All right. Now that we've looked through the visual representation of what we're trying to do, let's now try to code this. So we're going to have our solution vector, which we're going to return. And we're going to have an unordered map, which will be our hash map. And we'll call it hash. So let's start with the loop. We start from I equals 0, and we loop until the end of the vector. So now we calculate our first value, which we talked about. So it's going to be target minus the current value, which is nums of I. And so that's our first step. Now we're going to search in the hash map for hash of val. Basically, how we're going to do this, if we're going to go hash of val is not equal to hash dot end. So that basically means that if it's not at the end of it, that means it must be somewhere in the hash map. That's the logic of this if statement. So we're going to push back hash of val, and we're going to push back I. Finally, we're going to return the vector. And now we have our third step, which is to add the current element to hash. And we do this by saying hash nums by is equal to I. So yeah, that's about it, and we return solution here to avoid the error, the non-void function error. And yep, so let's just submit this code. Oh, hash oh, my bad. We have to use the find function here. Yep. So there you have it. Let's see. Passes all 29 cases. So that's basically how you code TwoSum. I'm just going to show you the code one more time, what I did. We go through each of the steps we looked through in the visual representation I gave you, which is calculating the value, searching for hash of val, and adding the current element to the hash table. So once this is done, we just return the solution there. And yep, that is how you do TwoSum.